Good morning to everyone. I'm the head of business development at xyzt.ai and will be your moderator today. Thank you for taking the time to join our first webinar with our reseller in Australia, Dedicated Systems, entitled Accelerate Your Mastery of Traffic and Mobility Analytics. First of all, I would like to introduce you to our speakers. Dave McIver. David is a technical computing specialist at Dedicated Systems who has spent most of his career developing simulation, modeling, and analytics, which leverages high-performance computing. And Bart Adams. Bart is the founder and the CTO of xyzt.ai, held senior leadership positions at Luciat and Hexagon, and Bart also holds a PhD computer science from KU Leuven and a postdoc from Stanford University. Shortly, Bart will go through the agenda, but before we start, a few points to mention. For some interactivity, we will ask you some questions during the webinar. If you have any thoughts or questions, you can ask them via the chat or the Q&A. We will try to answer as much as possible at the end of the webinar. Otherwise, we will definitely reply to your questions via email. The webinar is being recorded and will be shared with you as soon as possible after the event. Please mute yourself during the webinar. So for now, I will hand over to Bart to go through the agenda and start the webinar.
Thank you, Nick, and thank you all for joining today, and thank you, Dave, for being with us, and also thank you, John from Dedicated Systems and the whole team. So the agenda today is we're going to introduce you to the concept of mobility data and mobility analytics, and basically we want to help you to become a master. So the first topic will be about the data, because the data is going to be the fuel to your analytics. We will then show how to extract insights using something called spatial temporal analytics. And we invited Dave today to join us because he has a really nice case study on public transit delay analysis. And finally, we will have some time for Q&A. So please, as Nick mentioned, if you have questions, you can put them in the chat. So what is the goal? The goal is really to become smarter. To become smarter, cleaner, and safer, to become a smarter city, to become a cleaner city and a safer city. And this is not just about the city itself, but it's also about the mobility, to get to the city, to move inside the city, to move throughout the city. And we call this smart mobility. And if you want to become smart in your mobility analytics, you have to become a master in knowing what data exists and how to use the data. Otherwise, our cities will end up like this, and also our car manufacturers might end up like this. So the goal of this webinar is really to teach you what data is there, what new data is there, and what analytics can be done to become a master. And if you don't, we will miss you, because this is really a hot topic and many analysts are jumping on these new data sources and using them for their insight generation. So the type of data we will be demonstrating today is, on the first hand, floating vehicle data. And what is floating vehicle data? It is data from connected vehicles. So these days, new modern vehicles, they're connected to the internet, and they always send out basically IoT sensor data from the vehicle. So it is the position where the vehicle is, when the vehicle is there, so a timestamp, and then all types of attributes, such as, most importantly, the speed of the vehicle. And if you combine all these waypoints together, you get trips. Trips that tell you how people move throughout the city, how people move along the highways. The second type of data that we will be showing will be GTFS data. And Dave, GTFS data is where you are the expert, so I'll let you introduce the data shortly.
GTFS data came from all of the mapping applications we use on our phone. They created a demand for consumers to know exactly when their buses were arriving, buses, trains, and trams. And so transit operators started fitting their vehicles with real-time sensors that transmit the location of the data in latitude and longitude, and various attributes such as the speed, the level of occupation, how many seats were left. This data was so useful that Google developed a general feed specification, which is being used by most transit operators. And what that means is that people from the general public can plug into these feeds just like Google Maps can, creating a great amount of data that we can use from many cities around the world.
Okay, thank you, Dave. So in a sense, it's similar data, and it's about tracking the vehicles, tracking the location. So before we move on, Nick, we have a poll question.
Yes, first poll question of today. What data sources are you using right now? A, open data, B, traffic counting data, C, floating vehicle data, D, I'm looking for good data, or E, other. Okay, so most of you use open data or are looking for good data, which is quite interesting. Bart?
All right, that's exciting. Now, one of the big challenges, and Dave, you know, you've been working with the data, is that the data is big. And with big, we mean so big, so large that existing tools or tools that you are using nowadays, they cannot handle the data easily. Secondly, the data is not just big, it's also special. It's spatial temporal. And what we've seen over the past years and over the past decades is that doing analysis on spatial temporal data is not easy. Things move around and things change in time. So you have both a combination of spatial and temporal. So just to give you an idea of how big the data is, and this is a statistics from a company called INRIX, and they are in the business of collecting floating vehicle data and merging data from different providers and making the data available to the mobility market. And they collect about 33 billion location records a day. So it's a lot of data. And also in the GTFS space, there is a lot of data being generated. So Dave, I think this statistics is for NSW, and it's about 2 billion records a year. So even there, it's a lot of data, and we will show the data shortly. So what happens if you basically try to open the data in an existing tool, maybe in your web browser, using an open source tool? This is what typically happens. Your browser crashes, and you get basically an out of memory error. And this already happens from 250 megabytes of CSV files. So in this setting, when 33 billion records a day are generated, 250 megabytes is really small data. And that's what we solve with xyzt.ai. So the data is exploding and the existing tools cannot handle. But also secondly, the existing tools are very poor at handling temporal data. And especially GIS tools are not made for IoT type of data. And then finally, if you start using a data science workflow, we also see that it takes way too much time to develop algorithms and to extract insights using, for example, Python. So what we did with xyzt.ai, we built a tool, the xyzt.ai platform. It's a very visual tool, but it's also a very interactive tool, and it scales really to billions of floating vehicle data points or other data points. You can bring your own data. So anything that I will be showing later, you can also do with your own data. We made it very easy to use. So you don't have to be a developer. You don't have to be an expert GIS user to use a tool. It's very similar to a BI tool, with the big difference that it scales to big data and also that it handles time as a core dimension. The screenshot that you see is with floating vehicle data, but it of course also works with network data or data defined at fixed locations like stops or road segments or public transit network segments. So just to summarize, we are with xyzt.ai at the intersection of BI, GIS, and time series analysis. So to make things more concrete, let me just show the platform quickly before I let Dave speak and give him the floor to present what he can do with the platform with the public transit data. So what I'm going to do is I'm going to switch to my browser like this. So let me see if I can bring my browser up. I'm also going to put it in full screen. So basically what you see here is one of the analytical pages in the platform. So as on the screenshot, you see there's a map with the data. Now it's showing a heat map of floating vehicle data records, and I'll talk about this in a minute. Here at the bottom, you see a timeline, and the timeline basically now shows a histogram of 4 weeks of data. There's like 2 weeks in November and 2 weeks in December that we're going to be using for analysis. Here on the right side, you see different controls to manipulate your data. And you also see these little widgets, and these widgets give you insight on the attributes of the data. And basically everything is coupled. So what you see on the map, you also see on the timeline, and you also see in the statistics. Now this case is a case that was done in Germany. And Germany is a big country with a lot of highways going north, south, east, west. And this particular case was an issue that was happening in a very small town called Lüdenscheid. Lüdenscheid is in North Rhine-Westphalia. And if I click on it and zoom on it, you will see that there's a major highway running north to south and south to north, very close to the city. So this orange line here is the highway, the A45, and here is the city of Lüdenscheid. So basically, the heat map that you're looking at is showing the amount of movement, the amount of traffic along the different roads. So you see it's very dense, it's very wide, which means there's a lot of traffic along the highway. And what was the issue there? There's a bridge on the highway, and I'm going to try to zoom in on the bridge if I can find it, this one. It was structurally damaged. So basically they had to do maintenance on the bridge, and basically they had to repair the bridge and close off the highway. So what was happening then, traffic went off the highway. Basically traffic was diverted off the highway into the regions around. And the organization responsible for the highway, they have a very good view on what is happening on the highway because they have traffic cameras and they count traffic along the highway, but they're not responsible for the small roads, and they didn't know what was happening. And so they got a lot of complaints from the city, from the citizens in the city, that there was just too much traffic, too much congestion. And with floating vehicle data and with our tool, they can now assess or quantify what is happening, and whether it's getting worse, getting better, what is the situation? So basically they get situational awareness, they get a view on what is happening. So let me show you what was happening. So the 2 weeks in November, these are the normal weeks. This was when the highway was still open. And you see most traffic is flowing through the highway. Now, if I go to the other weeks in December, when the traffic was closed, you see there's a little bit of traffic. There's a few dots, a few GPS dots on the highway, probably from the maintenance trucks. But you see most traffic is diverted here off the highway and basically back onto the highway at this system. So what you see here is traffic is diverted off and you also see that it's going in 2 directions here. So you see, you immediately can see just from looking at a heat map of the traffic, you see that there's a lot of traffic going through the city. Now, if you want to analyze what is the impact of the traffic going off the highway, you can just filter this traffic out. So what I'm going to do is I'm going to draw a little circle here, and I'm going to call this shape the south shape. And this shape, I'm going to use as a filter. So what I'm going to do is I'm going to ask for only the traffic that comes from this area. So basically what you see now is you see that we only plot the vehicle dots, the floating vehicle dots, for the trips that started or passed by this area. So basically we're looking at traffic that goes through this area, and we're only looking at the dots after the trip went through this area. So you see now you get those insights on how traffic flows off the highway. Now, I can do the same on the other end of the highway, and I'm going to apply a filter here at this section, and I'm going to ask for traffic only going to this area. So basically, by applying these two filters from the south shape to the north shape, I get to see, and I'm going to make the background a little bit darker, I get to see how traffic flows from south to north, and then looking really at the traffic that would normally be on the highway. So what I get to see now, I get to see on the density map the major routes taking by this traffic. You see that it's going through the city here. You also see there's a lot of traffic going north here, and you see here there's a lot of congestion. It gets brighter, but also in the city of Lüdenscheid, you would see that there's a lot of congestion. If we then want to analyze, for example, what is the velocity profile, what I can do with the platform is I can just zoom in on the area that I'm interested in, and because everything just is coupled together and everything updates while moving and filtering around, I get to see what the velocity profile is. What I can also do, of course, is I can color the velocity. And just by looking at those colors, I get to see where traffic is waiting for example, congestion or traffic lights. And this allows organizations, departments of transportations, or city analysts or road analysts to really gain insight into what is happening from the data, from the mobility data. And this is something, if you would have to go out and start counting or start putting infrastructure in place, like those counting lines or traffic cameras, it would cost you a lot of effort to do so, not just in money, but also in time to deploy this infrastructure. And with the data, with the floating vehicle data, you can just go in and analyze any situation, any before and after analysis. So this short introduction to the platform, there's a lot of capabilities, and Dave will tackle a little bit more. It's not just about analyzing, but it's also about reporting on what you do, building dashboards and sharing those dashboards. But that is all possible in the platform. So let me switch back to my slideshow here. And before we move on, we have another poll question, Nick.
Yes. Second poll question for today. What self-service analytics tool are you using right now? A, Power BI, B, Tableau, C, a custom build solution, D, I need a good tool, or E, other. And here we are with the results. Most of them are looking for a good tool. So this is quite interesting information for us.
Okay, good. And I also see some Power BI, Tableau. So for sure, if you're using those tools, using the amount of data, like the type of data that I showed, will be a real challenge. And you would have to summarize the data probably before being able to ingest it in the tool. So with that, I would like to give the floor to Dave. Dave will give another demo with another type of data, and the data is called the GTFS data. So Dave, please go ahead.
Thank you, Bart. Yeah, when we partnered with xyzt, what we wanted to do was present a really compelling demo, and we looked around for different types of data that were available. And what we've noticed is that, at least in the Australia and New Zealand area, there's a lot of very good open data available from the transport operators. So we wrote some middleware that takes the GTFS feed and the GTFS real-time feed and combines them to produce ongoing data sets that we can use to analyze different traffic conditions. These data sets become very large very quickly. So a tool like xyzt is the best solution to very quickly ingest these and to make sense of these. You can see in the table down on the left from the providers that a moderate sized city like Adelaide is still generating 500,000 records a year. And as you get to a larger network, such as the one in New South Wales, that you're generating over 2 billion records per year. So if you want to do any type of long-term analysis on these, this data that's being generated, then you need a very robust backend and very robust tool. What I'm going to do is I'm going to share my screen and I'm going to show you some of the Adelaide Metro data. So you should be able to see the Adelaide Metro network data now. This data is coming in real time from the GTFS feed using some middleware that we've written. And I've configured the platform to show the last 28 days of data. I've done that because I can configure the time filter to track the most recent data minus 28 days. So every time I open the software, I get the most recent 28 days of data that's come through. You can see there in the heat map, the major transport corridors with whiter values being the more signals coming through and bluer values being lesser signals coming through. What I'm going to show you how to do with this data is create a heat map of areas that are experiencing delay. So one of the legends that we have available is this trip delay. Trip delay here, we're calculating by comparing the real-time vehicle location with its expected location from the timetable data. So if I switch the software over to trip delay, what you see is the legend has changed, and now we have a heat map there. But of course, as data analysts, we know that it's never as simple as that. So what we noticed is that there are some areas showing a very high delay that didn't make a lot of sense. I'm going to zoom into one of them here. What you can see as I zoom in is that the software is adapting to show all of the records on the screen. I'm now able to focus in on the trip delay for this particular area. And what you can notice is that in the very high levels of trip delay, and trip delay here is in kilometers, it's showing an excessively large number. Over 60 kilometers of delay for some of the buses in this area, and that doesn't make a lot of sense. So what we're able to do very quickly with xyzt and our domain knowledge of transit networks is to look at the records. So I'm seeing here that the major routes that are showing as causing delay are 2 train lines and a bus route 300. So I'm going to use the software to, firstly, I'm going to filter in only on buses. And now we can see that route 300, a lot of the signals coming in are showing delay. So let's have a look now just at the route ID of 300. What's going on there? I'm now going to show you that with xyzt, you can bring in multiple different complementary data sources. I've configured the software with the vehicle data source, which is the real-time feed, but also a routes data source, which is a geospatial data source consisting of the polylines of each of the transit routes. So we're going to go over to this one, and I've already filtered this one to show only route ID 300. And what we can do, we can conclude through a visual inspection that there are some legitimate delays that are appearing on this route that you can see over to the east and the west, but there are lots of significant delays that do not appear to be on the transit route. A bit further investigation shows us that these delays are coming from the transport depots. So here we have the northern depot. So what we can conclude is that we actually have some false positives, as in false delay data here, where some of the buses are turning on their trip computer, probably still associated with the previous trip that they did. And so we're getting some excessive excessive delays that are being reported. Fortunately, with xyzt, we can very quickly clean these up by removing, in this case, we're just going to filter out the offending routes. So let's now include all of the bus data, but now we're going to route 300. We're now going to exclude route 300. So you can see the areas of large delay around the Arndale area in Adelaide have now been removed. And now our trip delay profile is starting to look a lot more reasonable. There were 2 other areas that I know from investigation, which are the 747 and 745. I'll exclude both of those. There we are. So using our domain knowledge, what we've been able to do is very quickly clean up the data and produce a much more reliable profile for trip delay, which matches what we would expect. So there is a heat map that we can then add as a widget to one of our dashboards, and we can share it with our stakeholders. Now, once we know where areas of trip delay, Bart showed you the capability xyzt has of drawing various geo-regions on the map display. I've got a number of geo-regions that I've drawn that represent different transport corridors in the Adelaide area. What we're able to do with those is produce some very interesting stories around what's going on in those transport corridors. And I'm going to show you one of them today, which is the dwell time analysis. So xyzt has a number of different analytics tools that you can see on the left of the screen. Visual analytics is the one that we've been using. The dwell time analytics is the most recent one that Bart and the team have added. What I've done is I've configured this dwell time analysis. Dwell time analysis is, so I should tell you what it is first. That's the amount of time that vehicles, in this case, vehicles are spending within the geo-regions that we've defined. So what we can do with this tool is we can look at the average dwell times and we can compare two different times. What I've done with the geo-regions is I've set up a dashboard here showing South Road, Norwood Parade, South Road North, and Winston Avenue, which is 4 different transport corridors in the Adelaide area. You can see a graph for those is on each of the panels on the left and the right. The time that these panels are looking at is they're looking from midnight yesterday, one day, and one day before. So we're comparing Monday and Tuesday, the dwell time analysis. What we can see is that in South Road, in the north section of South Road, buses are spending up to nearly 15 minutes traversing that particular transport corridor on Monday, but they're flowing much smoother on the Tuesday. And we can start to compare and understand the movement of the traffic. We can then use this data, we can export it to CSV, and that can be part of models that we're generating of transit analysis in the Adelaide area, which we can then use to inform updated bus timetables, for instance. So we can then add this to a widget, and then using the dashboarding capability of xyzt, we can very quickly make this available to our stakeholders if this is a story that they're interested in monitoring on an ongoing basis. And because the data is coming into the platform on a live basis, if we set up these graphs to be the most recent data minus 1 day and minus 2 days, we will have then an ongoing plot that will track the data live as it comes in for our stakeholders. So I hope this gives you an idea of the power of xyzt to show stories around transit analysis, identify areas, identify different anomalies that you might want to investigate and fix, and then produce dashboards that are of high value to your stakeholders with only a few point and clicks. It's an excellent no-code solution.
Super. Thank you, Dave. Awesome demo. Really cool that you used the newest features as well. So what I'll do is I'll just wrap up here with a couple more talking points. So let me share my screen again. So what Dave showed was a very clever use of the GTFS data, the GTFS real-time data, and the combination of both, because it's not just enough to know the real-time location of the vehicles, you also have to know the timetables, the routes, and so on, to be able to assess delay and compute delay and know what is going well, what is going wrong. Before I start concluding into what we talked about today, Nick, we have another poll.
Yes, indeed. Thanks, Bart. So we have our last poll question of today. Are you interested to find out more? I would say definitely yes, but there are a couple of answers possible. So A, yes, about the traffic analysis. B, yes about the public transit analysis, C, yes about both, or D, no interest for now? Okay, and here we have the results. So most of you are interested to know more about both.
All right, cool. So definitely reach out to Dave and his team, and we have the contact information on the last slide to know more. And yeah, Dave and his team will be able to help you because they've become a real expert on the platform, which is really amazing to see. And basically, just to summarize why we founded xyzt.ai and why we built this platform and are still building this platform is, if you look at the traditional data science workflow, and over the past decade, many organizations and many companies have started investing in data science and have hired data scientists. But typically what we see is the following. Extracting insights and basically starting to extract insights takes a long time. And we call this the old way. And the old way is you acquire the data, you get your, 1 billion data points. Because your tools cannot handle this amount of data, you have to extract and slice the data. And once you've done that, you start building algorithms, building Python scripts, using some open source. And that takes already quite a bit of time because that's difficult for spatial temporal data. Once you've done your algorithms, you start visualizing and validating. And typically what happens then is that you see that something is going on and you have to iterate and improve to change maybe a threshold, to change a filter, to change maybe a processing algorithm. And only then you can start building dashboards. And once you've done that, you've built your dashboards, you can deploy them. And only then your analysts, whether they're in your organization or in a different organization, they can start extracting insights. So basically of this whole timeline, 90% of the time is on development and only 10% of the time is on solving actual business problems. And that's why we have xyzt.ai. We call this the new way. And the new way is really you acquire the data, you prepare the data, ingest the data, and really starting then you can start extracting insights. And as Dave has shown, he could do it on real-time data, but he was also using historical data because the platform can accumulate the data and allow you to not just look at the real-time situation, but also compare it with what happened yesterday or the day before. And you can do that really from day one with the platform. We showed a lot of interaction with UI, but there's a whole API that you can use as well to interact with the backend and to basically automate anything that you want to do, from data ingestion to querying and so on. And as a result, what we see is that organizations that start using xyzt.ai, they spend much less time on this white line. They spend much more time on the blue line, really looking at the data, extracting insights. And that's really what we want you to become a master in as well. So how to accelerate your mastery of mobility and data analytics? First of all, you have to make a mind switch to not only look at infrastructure, not only look at traffic counting data, not only look at video data, but really look at the data that is generated by the vehicles themselves. And this infrastructure is there. You don't have to do anything about it. The data is collected, the data is there. So your time to insight by using data is really reduced drastically. Instead of taking months or years to build infrastructure or deploy infrastructure, you can do that just in minutes by basically downloading the data. As I hope we have shown, you can do it on big data. That's really where our technology is built for. And I don't know if you ever happen to download big data sets and then try to open them and handle CSV files of, 5 gigabytes and so on. It's a real hassle if you want to do it in your scripting tools. The tool is self-serve, which is a big asset for analysts. It's not a closed box. It's not a tool that comes with the data inside. You can bring your own data. You can also prepare data in a different way, ingest it in the platform. And it also allows you to avoid lock-in from a certain data vendor or lock-in from a certain data tool. And as Dave also showed, it's not just about analyzing data, but the real goal in the end is to report on what you found. And you can do that with the dashboards. You can share the dashboards also outside your organization with shared links. And that allows you really to monetize the analysis that you did towards your stakeholders with the tool. So those 4 points, I think, if you focus on them, become data-driven, be able to handle big data, be able to bring your own data, and be able to share your insights in a very interactive, live way, we think you can become a master in new mobility analytics. So I would like to thank Dave. I would like to thank Dedicated Systems and John's team, especially. They have been a supporter of us from the very early days. They're now an expert reseller of us in the region. So please reach out to Dave and the whole team there for your questions. But of course, we have some time now also to answer your questions as well.
Yes,
Nick,
indeed.
do you have a view on the question?
Yes.
Okay.
We do have some questions coming in. So the first question here that we received today is, can you explain a little bit more about how the licensing model of the xyzt platform works? Bart, I guess that one is for you.
Okay. Yep. So the platform is basically, we have 2 licensing models. One is a SaaS model, software as a service. Basically, you subscribe to the tool, and from immediately you can log in and start using the platform. So it means that not only the software is provided, but also that we host it ourselves in the cloud and manage it for you, and you get immediate feedback, immediate benefit from the updates. So that's a typical SaaS model, and there's different tiers. There's different tiers to cater to different needs, like amount of data, number of users, and so on. So that's the first model, the SaaS model. Second model is that, and we call it the on-premise model, is where you would license the software to be installed on your own hardware, on your own servers, or maybe your own cloud, your private cloud maybe. And that is also possible. So feel free to reach out to Dave and see what works best for you. But typically it is one of those 2 options.
Okay, thank you, Bart. Second question for today. Is it really a no-code platform? I think that a lot of people who are used to working with other tools where they still need to do some scripting or build their own dashboards, they are wondering if with xyzt.ai, we really don't have to code anything anymore.
Okay, maybe I can answer a little bit, and maybe Dave, you can answer about your experience. So in any case, the tool is like Microsoft Word, so to speak. It's there to be used. You can drag and drop data. You can configure your data in the tool with the UI, and you can start doing analysis. On the other hand, there's a whole API. And of course, the API, to interact with the API, you can use code. It's a REST API, but what typically people do is they make code bindings around the API, for example, in Python or TypeScript or Java or whatever language you prefer. And then you can interact with the backend through the API. And then the third part of the answer, and I'm looking at Dave now, is of course, before you get your data ready for the platform, sometimes you want to do some preparation, some coding on the data. And I think you, Dave, you did some preparation on the data to get your delay metrics associated with the trips and associated with the roads.
Yes. So when you've got your data coming in a form other than tables, And that's the case with the GTFS data. It comes in a form called a protocol buffer. You do need some middleware to turn that data into tables. And then fortunately with XYZT, they've got an API where you can directly upload it in real time as you receive it to the platform. So that's where you will need code. But in that case, you've already, no matter what solution you write, whether it's one of the open source ones or whether it's some other cloud hosted solution, you're going to need that middleware to get from the protocol buffer to the digestible data and to make the appropriate transforms and connect the static data from the live data. What struck us with the xyzt platform when we picked it up was how detailed the data configuration steps are that Bart and the team have built into the data import process. So it really is no code. If you've already got data in a table in CSV format and you're trying to work with it with various open source tools or other tools, you already have that data in CSV format. And from that point, it is quite literally a no code solution to get your data in and get it displayed using all of the drop downs that you saw. They were all done with the configuration on the way in for the data. There was no code that we needed to write to do anything within the platform once the data was in CSV format.
Okay, thank you for the clarification, Bart and Dave. Then another question that came in, Dave, that is more for you. People in the call are wondering if dedicated systems can also help them with integrating into the xyzt.ai tool.
Yeah, as part of our journey of becoming an expert reseller, we've had to master the different APIs of the software. And so, yes, we can provide hands-on support and also support your team to get up to speed with using the APIs and really leveraging the tool to its fullest extent.
Okay, thank you very much. That was the last question that we received for today. So I would like to still thank everyone who joined us today. If you still have any questions, don't hesitate, of course, to reach out to either dedicated systems or our own xyzt.ai team. After the webinar, we will send you an email within the next 24 hours, probably, with the links to all the recordings. And then last but not least, thank you very much, Bart and Dave, for this very interesting webinar. And then to all of you, have a nice rest of the day. Bye.